Hey guys, so today we're going to be talking about velocity to acceleration time graph.
Now, before we start on the graphs, let's find out what velocity and acceleration actually are.
But hold on, isn't speed and velocity the same? Well, not really. Velocity is the same as speed except for the fact that it has a direction. So, for example, my friend Bob here, he's walking off the page at 4 meters per second. Now that 4 meters per second would be your speed. However, if you want to find velocity, you need to find a direction. In this case, he's going to the right. So his velocity will be 4 meters per second to the right. Okay, so now that we know what velocity is, let's go to acceleration. Acceleration is the rate at which velocity changes over time, and its unit of measurement is meters over seconds squared. Alright, so now that we know the basics, let's go to... Oh, nope, don't want to go there. Alright, let's see. Oh, there's this ladder. Hopefully it can hold us. Yep, now it's graphing time. Okay, so we're going to look at two types of graphs. One is linear, and the other is non-linear, also known as curve. Now let's get started. Okay, so we're going to start off with a linear velocity versus time graph. Now before we begin, we have to make sure everything is labeled correctly. For title, you need velocity versus time, as well as a purpose. Now that purpose could be walking your dog or going across the street. You also need to remember to label your axis with time as x and velocity as y. Now let's take a look at the graph. From 0 to 1, velocity increases to 2. From 1 to 3, velocity remains the same. From 3 to 4, velocity increases to 5. From 4 to 7, velocity remains the same. And from 7 to 8, velocity drops down back to 0. Now in order to find the acceleration, you need to find the slope of each time interval. So in this case, that would be from 0 to 1, 1 to 3, 3 to 4, 4 to 7, and 7 to 8. Now, we're going to need the points of the ending of the time segments. So this will be 1, 2, this will be 3, 2, this will be 4, 5, this will be 7, 5, and this will be 8, 0. Now, in order to find the slope of 0 second to 1 second, we're going to need these 2 points. So we use the slope formula, y2 minus y1 over x2 minus x1, and that gives you the slope of 2. So that means from 0 second to 1 second, you get a slope of 2. Now, let's take a look from 1 second to 3 second. However, this is a horizontal slope, so that means there is no slope. So it becomes 0. Now, let's take a look from 3 to 4. We take these 2 points, plug it into the formula. 5 minus 2 over 4 minus 3 gives you a slope of 3. So, this slope from 3 to 4 is 3. Now from 4 to 7, it is again horizontal, so that means it's 0. Now, we go from 7 to 8. Now this is a downward slope, so we know it will be negative. So we plug the number in, y2 minus y1 over x2 minus x1, and it eventually gives you negative 5 as its slope. So this slope will be negative 5. Now since we know the slope, we can plug it in to the AT graph. So we look at the time segments. So I wrote the time segments the same because from VT to AT it will remain the same. So from 0 to 1, the slope is 2. That means we take 2 and draw all the way to 1 second. And then from 1 to 3 is 0. So that means this line has to drop down back to 0 and go across until it touches 3. From 3 to 4, slope is 3. So that means from 3, we have to move back up until it touches 3 over here, and then move it towards 4 seconds. From 4 seconds to 7, it is slope of 0. So that means this drops down back again and goes across the x-axis. Now, we have a negative here. That means we're going to go into the negatives over here as well. So, let's add a little bit more. Let's say this is negative 5. So then 7, this has to go down all the way to negative 5 and connect with 8. So this is how you change a VT graph to an AT graph using linear. Okay, so now we're going to focus on curved velocity versus time graph. Remember to put your labels for the title and the two axes.
Now let's take a look at the graph. So we can see in the beginning, it's pretty slow, but as time increases, velocity also increases. Now in order to change a curve into an acceleration versus time graph, we have to find the slope of tangents at specific points. The points we're going to use today are 2, 4, and 6. Now when you're drawing tangents, it's best to use a ruler so they can be straight. Now I've drawn the tangents beforehand, and the coordinates for the tangent at 2 would be 1.5 and 5 and 2. The tangents at 4 will be 3, 1 and 7, 4, and for 6 will be 5, 2 again and 7, 8. Now we know the two coordinates, so in order to find a slope, we use the slope formula. y2 minus y1 over x2 minus x1, which gives you 3 over 8. So you write that on top, 3 over 8. Now let's move on to the tangent at 4. So we take the two coordinates, sub it into the slope equation, and we get 3 over 4. So 3 over 4. And then now we look at the tangent at 6. We take the two coordinates, sub it in, and we get 3. So now that we know the slope of all three tangents, we can draw it on the AT graph now. So for the time at 2, the point is at 3/8. So then at 2, right here. And then for 4, the point is at 3/4. So that's 3/4, so somewhere right here. And then for 6, the slope is 3. So that we move up to 3, and we plot the 3 points. Now after you finish plotting the 3 points, all you have to do now is connect the points using straight lines. Now when you're connecting the points, it's best to use a ruler as well.